Okay, let's solve this recurrence relation where we have t of n equal to 64 t of n upon 2 plus n cube. So this 64 is our a, so we got a equal to 64, b equal to 2, and now we have this one as f of n, and complexity of f of n, if I represent, I'll be getting big O of n cube, and if you compare it with big O of n to the power c, we'll be getting c equal to 3. So we got c equal to 3, a equal to 64, b equal to 2. So now find out c critical, which is equal to log of a to the base b. Now what it is? Log of a is 64 and b equal to 2. So I'll be getting log of 2 and 2 to the power 6, right? So c critical equal to 6. So we got c is less than c critical. So what is the complexity of this? This is falling under case 1 of our master theorem, and now the complexity of this is c is less than c critical. That means we will be having complexity of t of n using Master's theorem, is theta of n to the power c critical, which is theta of n to the power 6. Okay, let's take one more example, which we can again go with this one. T of n, which is equal to, I'll just make it as 8 t of n upon 2 plus n square. So now we have again a equal to 8 here, b equal to 2 here, and again f of n, if I write big O of n to the power c form, I'll be getting big O of n square. So I'll be getting now c equal to 2 just by comparison. So now what is c critical, which is equal to log of 8 to the base 2. So now I'll be getting here as log of 8 to the base 2, which is again log of 2 cube to the base 2, which is again 3 by the property of logarithm. So again we have c less than c critical, then this is again falls under case 1. So if it is falling under case 1, we have complexity using Master's theorem, that is complexity of t of n using Master theorem is theta of n to the power c critical. And what is c critical here? 3. So we will get theta of n cube. So these two examples we have discussed for case 1. Let's discuss some examples of case 3. So what we will be getting? T of n, which is equal to 2t of n by 2 plus n square. So now t of n is equal to, compared with again t of n upon b plus f of n. So we will be getting a equal to 2, b equal to 2, and if I write f of n in terms of big O of n to the power c, I'll be writing it of the form big O of n square. So I'll be getting c equal to 2. So now we have c equal to 2 and c critical, which is equal to log of a to the base b, which is equal to log of 2 to the base 2. So log of any quantity to the same base will be 1. So now we have C greater than C critical. This is the case 3 of master theorem which we got. So this is the case 3 of the master's theorem. And now what we will be getting? The complexity of T of n using master theorem is theta of f of n, which is equal to theta of n square. Let's have one more equation, one more recurrence relation, and then we'll discuss some examples of case 2. So let's have this as T of n equal to T of n equal to, I'll just take it 4 T of n by 2 plus n cube plus log of n. I'll be just writing like this. So now if you just see, we got a equal to 4 here, b equal to 2 here, and f of n equal to n cube plus log n. So what is highest degree of f of n is 3. So even if I compare it with highest degree, I'll be getting c equal to 3 here. Okay. So we have a equal to 4, b equal to 2, and c equal to 3. So now let's calculate c critical. So c critical equal to log of a to the base b, which is equal to log of 4 to the base 2, which is equal to 2. So I am getting c critical equal to 2. So if you are having c critical equal to 2, what we will be getting? C equal to 3 we have. So we are in the again under case 3 of master's theorem, where c is greater than c critical. So now what is the complexity? Now again the complexity of T of n is equal to, and the complexity of T of n using master theorem is equal to theta of f of n, and we can write it as a theta of n cube plus log of n. Okay. So this is the complexity using master's theorem. So now we have remained with the case 2, which will again, it has 3 sub cases, so we will discuss that in next video.